just like every time I forgot to record the session. So currently I'm just activated that. I hope it is visible, everyone.
Yes, sir.
All of you. Let us be little bit quick. First day after long time I've touched this pad, guys, writing pad. So let us see. Little bit quick, okay? So basically, questions in ray optics will be asked from one question can be asked from reflection, one will be asked from refraction, other will be from optical instruments. So three topics are very important. Reflection includes plane mirror, concave mirror, convex mirror. Refraction includes lenses, prism, glass slab, right? Optical instruments are three optical instruments which you usually study: simple microscope, compound microscope, and astronomical telescope, right? You might have studied this in 10th class also, guys. So let me just move into second page. Is this clear, everyone? Right? If the reflecting surface, did you understand what is the meaning of reflecting surface? Did everyone understand meaning of reflecting plane surface? What is a plane surface, guys? What is a plane surface? It is a very small part of a very large sphere, guys. And if it is polished on one side, it is going to behave as a plane mirror. So we are talking about laws of reflection. First one is incident ray, reflected ray, and the normal to the point of incidence at the reflecting surface. They are all going to lie in same plane. So what is the major point that you need to know? The major point that you need to know is if they are forming a three-dimensional object, volume of that three-dimensional object will be 0. And the second important point is, as you all know, angle of incidence will be equal to angle of reflection. So suppose if this plane reflecting surface was not there, incident ray would have traveled in this manner. But because of the reflecting surface, it is traveling in this manner. So is there some deviation observed or not? Yes, there is some deviation observed. This will be our deviation, guys, which is given by delta. So what we can write here, we can write I and delta will be equal to 180 degrees. I and delta will be equal to how much, beta? 180 degrees. So what will you get the deviation as? You will get it as 180 minus 2i, or you will get the deviation as 180 minus 2r. So this is one more point that you need to know. Now, if you want the deviation to be maximum, what should the when will deviation be maximum? Very simple logic. Because it is written as 180 minus 2i, this term has to be minimum. Angle cannot be negative, guys. So minimum value of I can be 0. So if the value of I is 0, you are going to have maximum deviation. So that is the reason for maximum deviation, angle of incidence should be 0. What is the meaning of angle of incidence 0? It is angle of incidence is 0 means incident ray will be along the normal. So if incident ray is along the normal, after reflection it is going to retrace its path back. So you can see a ray moving along the normal always retraces its path, right? So if and again, I'm not going into all these things. So what is the maximum value of deviation, guys? The maximum deviation produced will be 180 degrees. When will the maximum deviation produced be 180 degrees? If the incident ray is falling normally on the reflecting surface. Clear, all of you? Is that clear, everyone? At this point, you need to remember in laws of reflection. Let us move ahead to plane mirror, guys. Right. So basic things that you need to know in plane mirror again. First, and I have told you what is the meaning of plane mirror. Again, whenever you take a very small part of a very large sphere, it is a plane surface. If it is polished on one of the face, it will behave as a plane mirror. Right. So if I consider some important properties of plane mirror, firstly, the object distance and image distance both will be equal. Clear, all of you? And magnification, so basically magnification is given as height of the image divided by height of the object. So here for plane mirror, height of the image and height of the object both will be equal. That is the reason magnification for a plane mirror will be equal to 1, guys. And two very important points that you should know in case of plane mirror. If I talk about velocity of the image with respect to the mirror, guys, velocity of the image with respect to the mirror will be minus of velocity of the object with respect to the mirror. Right? Very simple logic. If you are standing in front of the mirror, if you are moving towards the mirror, will your image move towards you or not? Yes. If you have covered some x centimeters towards the mirror, then obviously your image will also move x centimeters towards the mirror only. their directions are opposite. That is the reason I've written velocity of image with respect to mirror will be minus of velocity of object with respect to mirror. But there is a very small important point in this. Now, when I am saying velocity of image with respect to mirror is minus of velocity of object with respect to mirror, right? Am I taking that velocity which is perpendicular to the plane mirror or not, guys? This velocity you see, either you take this velocity or this velocity. Are these components perpendicular to the plane of the mirror? Yes. So when I will say this velocity of image with respect to mirror is minus of velocity of object with respect to mirror, it is valid for only those points which are perpendicular to plane of mirror, guys. It is valid for only those points which are perpendicular to plane of mirror. So you should take only those components which are perpendicular to the plane of mirror, guys. In the same manner, right? Whether if you consider something in this manner, let me move ahead. Right. If you are moving along the mirror, let us say, if you are moving upwards, your mirror is at rest, you are moving upwards. How will the image move? Will it move down? Obviously not. It is also going to move up only, guys. So what is the second point that you need to know? I am writing one more point now. Velocity of image with respect to mirror. I am saying it will be equal to velocity of object with respect to mirror. Right. Two cases are there which are very important. When I write velocity of image with respect to mirror is minus of velocity of object with respect to mirror, it is due to those components which are perpendicular to the plane of the mirror. And when I write velocity of image with respect to mirror is velocity of object with respect to mirror, which components I'm talking about, guys? I'm talking about those components which are parallel to the plane of the mirror. I hope it is clear, all of you. Let us be interactive, guys. Parallel to the plane of the mirror. This component also, if I take, this will be parallel to the plane of the mirror. Did you understand, everyone? These 2 points in plane mirror are very important again. Clear?
Yes, sir.
Right. So velocity of image with respect to mirror is minus of velocity of object with respect to mirror when only due to those components which are perpendicular to the plane of the mirror. Similarly, velocity of image with respect to mirror is equal to velocity of object with respect to mirror for only those components which are parallel to the plane of the mirror, guys. Is that clear, everyone?
Yes, sir.
Right. So what do we need to know? And majorly this part will be asked, guys. So what do we need to know? I think whether first year or second year or long term students, you know relative velocity concept. Velocity of a with respect to b is given as velocity of a with respect to ground minus velocity of b with respect to ground. So as simple as that. How can you also write this? I can write it as velocity of image with respect to ground minus velocity of mirror with respect to ground should be equal to minus of velocity of object with respect to ground minus velocity of mirror with respect to ground, or not? I hope this point is clear, everyone. What we can write velocity of image with respect to ground minus velocity of mirror with respect to ground as, I can write it as 2 times of mirror with respect to ground minus velocity of object with respect to ground. So velocity of image with respect to ground will be 2 times the velocity of mirror with respect to ground minus velocity of object with respect to ground, guys. This is again very important point. Velocity of image with respect to ground is 2 times the velocity of mirror with respect to ground minus velocity of object with respect to ground. I hope it is clear. And these 2 points are valid only for those components which are perpendicular to the plane of the mirror. Which are parallel to the plane of the mirror, velocity of image with respect to mirror will be velocity of object with respect to mirror. Or I will write again the same thing if we are trying to write from this. So I'll get velocity of image with respect to ground minus velocity of mirror with respect to ground will be equal to velocity of object with respect to ground minus velocity of mirror with respect to ground. So automatically you will get velocity of image with respect to ground will be velocity of object with respect to ground. I hope these two are clear, everyone. Yes or no? Is that clear, all of you?
Yes, sir.
Yes, sir.
I hope so. Right. So let us move to the next points in plane mirror. So again, please remember important points, guys. And apart from remembering important points, also please remember important formulas, because every concept, as you know, I cannot deal with every concept in a very short period of time. However, as you can see in the 15 minutes, I'm still in one page. I'm trying to discuss every point in detail, but which is not possible, guys, right? So I'll make that point clear once again. So image will be laterally inverted. You all know, right? If you are placing the object like this, image will be in this manner, right? And very important point, which was asked in AIPMT, which is fifth point, guys. It's a very important point. If you are fixing the incident ray, and if you are rotating the plane mirror, guys, let us say I have fixed the incident ray in this manner. I have rotated the plane mirror clockwise by a certain angle theta. The reflected ray will also get rotated in the same direction by double the angle, guys. So as you can see, keeping incident ray fixed, if you are rotating the plane mirror by an angle theta, reflected ray will get rotated by how much angle? 2 theta. Incident ray, though, I think you all know, no? Yes or no? Incident ray, reflected ray, these terms I believe that you are aware of,
Yes, sir.
right? So if you take a plane surface, plane mirror, right? If I take this as the incident ray, I'll just show you in this manner, guys. So if I consider this to be plane surface, we have an incident ray. Incident ray is fixed again, right? So this will be our point of incidence, and this would be our normal. As we all know, this will be our reflected ray or not. This is our reflected ray. And as per laws of reflection, angle of incidence, we know it is equal to angle of reflection. R value will be equal to I value. Angle of incidence will be equal to angle of reflection. Now you see, if we are rotating the mirror by an angle theta in clockwise sense, I am fixing this incident ray, guys. Incident ray is fixed. If plane mirror is rotated by an angle theta, what will happen to reflected ray? In the same sense, it will get rotated by an angle 2 theta, guys. It will get rotated by an angle how much? 2 theta. This point is very important, that has been asked in previous year exams, guys. 2015 it was asked when AIPMT was being conducted. Okay. 2019 also it was asked, guys. Similarly, now they'll ask you what would be the number of images formed by a plane mirror, right? If we are taking two plane mirrors, guys, did you understand the meaning of plane mirror? Class 11th students, did you understand the meaning of plane mirror? 11th class students, did you understand the meaning of plane mirror?
Yes, sir.
Right. So let us take two plane mirrors. If they are inclined by an angle theta, then what will be the number of images formed for an object placed in front of them? They'll ask, guys. So let us say object is placed somewhere over here. Two plane mirrors have been taken. They will ask you to find number of images formed. So in this case, what you will do is first you will calculate a certain value. And what is that value? It is 360 divided by theta. What you are going to calculate? You are going to calculate 360 divided by theta. So two plane mirrors are inclined to each other by a certain angle. Object is placed in front of the two plane mirrors. They will ask you what would be the number of images formed. Okay, so n value will be given as 360 by theta, guys. First, you have to calculate this value. Let us say theta value is 60. What will n value be? What will n value be? 360 by 60. How much is it? 6 or not? Now, please tell me, is it even number or odd number?
Even.
Even number. So you see, if n value is even, then in that case, how many images will be formed? N minus 1 images will be formed, right? So if two plane mirrors are inclined by an angle theta, you will first find out a value called as 360 by theta, which we take it as n. If this value is even, how many images will be formed, guys, by the combination? N minus 1. Let us take, if I am getting this value as odd, guys, let us take theta value is, let us imagine 72 degrees. Okay, or you take 12, right? 120 degrees you take. Theta value is 120 degrees. How much will you get n value?
2.
अरे 360 by 120 is 2. कहाँ से आ गया
3.
भाई? Right, it is
3.
3. Yes or no? So is that even or odd? Odd. So in odd, no, you have two cases. We need to check whether the object is placed symmetrically or whether the object is placed unsymmetrically. What do I mean by symmetrical placement of the object? Symmetrical placement means the object should lie along the angle bisector. So suppose if I say this totally is 60 degrees, what is the meaning of symmetrical placement? This should be 30. Similarly, this will also be 30. This is called a symmetrical placement. If I take 120 degrees, then in that case, this should be 60 and this should be 60. So whenever object is placed along the angle bisector or on the line which is along the angle bisector, then such placement is called as symmetrical placement. Other than that, it will be called as an unsymmetrical placement, guys. So when n is even, how many number of images? So suppose if I have taken 60 degrees, let us say theta value is 60 degrees. Theta is 60 degrees. What did you get n value?
5.
అరే అరే ఏం రా భయ్ నిద్రపోతుర్రా 360 by 65 ఎట్లా అయింది భయ్ n value how much you got?
6.
N value you got 6, which is even or odd?
Even.
Even. So how many number of images will be there? N minus 1, which is 5 images.
5.
Clear all of you? Now what I have taken theta value as 120 degrees. If theta value is 120 degrees, what is n value?
3.
Right? Is it 3 or not? So because it is 3, is it even or odd? Odd.
Odd.
Whenever it is odd, you need to check whether it is placed symmetrically or unsymmetrically. So what is the meaning when it is placed symmetrically or unsymmetrically, guys? Symmetrically means it should be along the angle bisector. Unsymmetric. So when it is placed symmetrically, number of images formed will be n minus 1 for symmetrical placement. And similarly, for unsymmetrical placement, the number of images formed will be n itself. So please tell me how many images will be formed if symmetrical placement is there? How many? 2 images. And how many images will be formed if unsymmetrical placement is there?
3.
3.
3 images. Is this clear, all of you? Yes or
Yes,
no,
sir.
everyone? Right? Now, so odd ho gaya, even ho gaya. What about fraction, guys? Right? Let us take theta value as 70 degrees. Right? I am taking theta value how much? Theta value, you are taking it as 70 degrees. So what will n value be? You will get it as 360 divided by 70, which is 36 by 7. Can you please tell how much is this value? Near about 5 point something you will get. Yes or no? 5.14 you will get. Is this a fraction or not? Is this a fraction? 36 by 7. Did you get odd number or even number? No, we got a fraction. So whenever we are getting a fraction, how many images will be formed, they will ask you. So what will be the number of images? We got the number which is 5.14. What is an integer close to 5.14 and less than 5.14? Integer means I think you all are aware. -1, -2, 0, 1, 2, 3. These all are integers, guys. Right? So I got the value as 5.14. Is it a odd number? Is it
Yes.
an even number? Arey, odd etlaitadi, even etlaitadi ra bhai. Is it odd or even? No, it is neither odd nor
Fraction.
even. It is a fraction. So which value is closer to this fraction and less than the fraction?
5.
5. So how many images will be formed, guys? 5 images will be formed if it is fraction. Number of images formed, understood, everyone? Yes or no?
Yes.
Right. I hope it is clear. Now, majorly, you all remember that plane mirror will form only a virtual image, which is wrong, guys. Plane mirror can form a real image also. So as you can see, if we have convergent type of beams, if you have convergent type of beams incident on the converging means they are coming towards each other. Diverging means they are moving away from each other. So if I have divergent type of incident rays, virtual image will be formed. But if I have convergent type of incident rays, which image will be formed, guys? Real image will be formed. So plane mirror can form a real image also. So what are the points to remember in plane mirror? Please remember, right? Once again, I'm telling, first and foremost, object distance and image distance, both are same. Height of the image, height of the object, both are same. So magnification will be 1. In the same manner, right? These 2 points are important. Velocity of image with respect to mirror is minus of velocity of object with respect to mirror. When is this true? It is only true for those components which are perpendicular to the plane of the mirror. Similarly, velocity of image will be velocity of image with respect to mirror is equal to velocity of object with respect to mirror. For which components is it true? All those components which are along the plane of the mirror. Is that clear, everyone? Yes or no?
Yes.
Yes, sir.
And the next important point in plane mirror to remember is keeping incident ray fixed. If mirror is rotated by a certain angle theta, then reflected ray will get rotated by an angle 2 theta in the same sense. And the other point is number of images formed, guys. So if two plane mirrors are inclined to each other by a certain angle theta, then I'll calculate n value. If n value is even, number of images formed will be n minus 1. If n value is odd, I need to check whether the object is placed symmetrically or unsymmetrically. If it is placed symmetrically, the number of images formed will be n minus 1. If it is placed unsymmetrically, then the number of images formed will be n itself. right? In the same manner, if we are getting the value as a fraction, then number of images formed will be an integer closer to the fraction or closest to the fraction less than the fraction value. I hope it is clear, everyone. Yes or no?
Yes, sir.
Right. And also remember, can plane mirror form a real image?
Yes.
Yes, it can form a real image. uh, how will that real image be formed? If you have
Watching
convergent
rays.
type of
Converging.
rays. Clear? Am I audible, everyone?
Yes, sir.
I,
Yes,
Yes,
sir.
sir.
I'll stop presenting for a while. Okay. So plane mirror part we have seen. I'm going to discuss the other parts also. But there are people who are new, right? They don't know me, and there are people who know me from very long. There are people who are attending the class for the very first time, right? So all those people who are attending the class for the very first time, let me make things clear to you people. I cannot teach everything in detail as you are expecting in 40 days, but I'll try my best to teach everything in detail as I have been doing for the past half an hour, guys. Okay. Once again, I'm giving a clarity to all you people. What you have to majorly focus on is, please solve previous year questions of that particular chapter. I am going to make you solve some questions. I will explain how to solve this type of question, that type of question. But during these 40 days, review, you listen to what I am discussing already. One class I'll give for review of the chapter, one or two class I'll discuss the problems, guys. Time is not a constraint. I'll sit with you people for 3 hours, 2 hours, 4 hours, whatever it may be. I'll sit with you people because తిరిగి ఇంట్రెస్ట్ తో పాటు ఇచ్చేయాలి కదా మరి 2-3 months. I think I've not taken for 3 months, maybe 3-4 months, I guess, right? So I have to give it back with interest, no? So I'm willing to give it back with interest, guys, right? But what I'm expecting from you people is, you just focus on the review. You listen carefully. Review, you listen carefully, right? After you are listening to the review, please focus on solving previous year questions. What do I mean by previous year questions? Not only NEET questions, guys, you have to solve AIPMT questions also. There are people who have come for MSET also, I guess. So you just focus on remembering the formulas, and whatever MSET physics book is there with you people, you just solve questions from that. I hope it is clear. Class 11th students, please consider this as a beneficial course moving into class 12th again. As simple as that. You will be learning few things of class 12th. Whatever you might not have learned in class 11th, you will also learn those things. I hope that is clear, everyone. So what I am expecting from you people to solve, I am just expecting you people to solve previous year questions, whether they are 50 questions, 60 questions, 100 questions in a chapter, you please solve it. On an average, if the chapter is small, you will have 40, 50 questions, right? If the chapter is large, you are going to have 80 to 100 questions, guys. Is that clear, everyone? I hope it is clear, all of you.
Yes,
Are
sir.
we on the
Yes,
same
sir.
page? Right, you please focus on solving previous year questions, as simple as that. Test will be conducted, right? Whatever the test schedule is there, I have already shared it with you people. Even then, I'm going to post everything once again in the group, the test schedule and all. I'm going to post it. So just track your status as per the teaching schedule and the test schedule, guys. Please focus on the review session. Please solve previous year questions, right? And do the test, right? As simple as that. You follow these three-step procedure for the next 35, 40 odd days. Certainly you can score 35 questions correctly, guys. So each day one question. Our target is, each day I have to learn one question. If that question is turning up in the exam, I have to solve it. As simple as that. I hope it is clear.
Yes, sir.
Yes,
Right.
sir.
And please have some patience, guys. It's a very small time, so please have little bit of patience. Right, in your mind, so many deviations will come. They are enjoying, I should also enjoy. Why should I listen to 1.5 hour class, 2 hour class? I can do something else. If you want to do something else, be out of the creative column course, guys. As simple as that. Whether there are 5 students, 10 students, I am willing to teach to them. Okay, so that is a dearest advice from the bottom of my heart, guys. I hope the board is visible. Is it visible, guys?
Yes,
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 sir.
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 I'm not dealing with sign convention. I hope you all are aware of the sign convention, guys. So I'm not dealing with that. However, there are certain terms that you should be aware, right? One is center of curvature. What is center of curvature? If I say, just like we have studied just now, that there is something called as a plane surface. So what do I mean by plane surface, guys? It is a very small part of a very large sphere. Yes or no? Right. So if this plane surface is polished, it is going to behave as a plane mirror, right? Because it is a large sphere. So will it have some center or not? So this center will be called as your center of curvature, right? And if you take the plane surface, I'm just enlarging it, guys. In reality, it is very small again. So you are also going to have something center of the plane surface. So center of this reflecting surface is called as pole. You might have studied this. From center to pole, you are going to have something called as radius of curvature. Line passing through center and pole will be called as principal axis, guys. Okay, so you also have some other terms which are as of now not required. I hope it is clear, all of you. So can you tell me what is radius of curvature for a plane mirror? What will radius of curvature for a plane mirror be? Plane mirror is a very small part of a very large sphere, guys. So it will basically be infinity, but if I take the sign convention, it will be minus infinity. Why? Because all the measurements should be taken from the pole. Clear, all of you? So from pole to the center. So is it being measured along negative x-axis or basically opposite direction of incident rays we can take? So radius of plane mirror will be minus infinity and focal length of the plane mirror will also be minus infinity because focal length is in general given as r by 2 is radius of curvature divided by 2. Okay. Is that clear? Yes or no?
Yes, sir.
Right. Now, as you can see, let us see the rules. There are basically four rules, guys, which you are already aware of. Right. Now, you see in this case, a ray passing parallel to principal axis after reflection from the mirror passes or appears to pass through focus. Right. This point, incident ray parallel to principal axis after reflection converges at focus or appears to diverge from focus. In the same manner, whenever it is passing through focus, it is going to become uh, the reflected ray will become parallel to the principal axis. If it is passing through center of curvature, it is going to move undeviated, guys. And whenever incident ray is incident at pole, right? Pole is considered as plane mirror, guys. What is pole considered as? Plane mirror. And whenever you draw a normal to the plane mirror, normal to the sphere will always pass through center of curvature. So pole is a point. Yes or no? Pole is just a point on the reflecting surface. Point, can I consider it to be very small part of a very large surface or not? Yes. So pole behaves as a plane mirror, guys. So this is nothing but your plane mirror. So incident ray, incident at a particular angle will get reflected by making the same angle, guys. As simple as that. I hope it is clear. Rules for image formation, I'm not going in detail about that. You might have studied every time again. So I'm not going in detail about rules for image formation. Is that clear, all of you?
Yes, sir.
Yes, sir.
Right? Right? So I hope these points are clear to you all. So I'm not dealing with rules for image formation. Now, what is important is this, guys. So important relations in case of spherical mirrors, which will help you in finding out or in solving the questions again. So in general, first thing, incident ray, as I have said, when it is incident, when it is parallel to the principal axis, will it converge at a point? Yes, as you can see in this case. Is it converging at a point, guys? Incident ray parallel to principal axis is converging at a point. All measurements should be taken from pole. So from pole to center of curvature will be your radius of curvature. From pole to your focus will be your focal length. Now, because they are being measured opposite to the direction of incident ray, they will consider as negative, guys. Okay, you have from pole to focus will be our focal length. Okay, now, right, so as I was talking about some important relations, let us move on to important relations, guys. Please remember these important relations because they're going to help you a lot again. Right. First thing, focal length will be half of the radius of curvature. But when I say it is half of the radius of curvature, it is only for paraxial rays, guys. It is valid only for which rays? For paraxial rays. What do I mean by paraxial rays? Paraxial rays are those rays which are parallel to principal axis. So if I say this is principal axis, paraxial rays are those rays which are parallel to principal axis and close to principal axis. We also have something called as marginal rays, guys. What are marginal rays? They are also rays which are parallel to principal axis, but they are going to be a little bit far away from the principal axis. So for that case, you are going to get focal length as, you can write it as r. If I take common, guys, you will get it as 1 minus 1 by 2 cos theta, guys. Is that clear, all of you? Everyone, is this clear or not?
Yes, sir.
Right, this is the focal length formula for which type of rays? Marginal rays. What are marginal rays? Those rays which are parallel to principal axis but a certain distance away from principal axis. What are paraxial rays? Those rays which are parallel to principal axis and close to principal axis will be called as your paraxial rays. For paraxial rays, it is r by 2. For marginal rays, it is r into 1 minus 1 by 2 cos theta. So what will happen to theta, guys? Theta value, if you consider for paraxial rays, because they are very close to the principal axis, for paraxial rays theta value will be 0. So if theta value is 0, cos 0 will be 1. What is 1 minus 1 by 2? 1 by 2. So is focal length again becoming r by 2 or not? Yes, this will become r by 2. The next important formula happens to be, this is of focal length. Next is mirror formula. What is mirror formula? 1 by v plus 1 by u is 1 by f. Similarly, we also have magnification. Magnification is given as height of the image by height of the object. In terms of image distance and object distance, it is given as minus v by u. In terms of focal length and image distance, it is given as f minus v by f, or f divided by f minus u, guys. And always remember, if you have an inverted image, the magnification of that image will be negative. If you have a upright image or erect image, we call it as. If you have a erect image, the magnification of that particular image will be positive, guys. Is that clear? Three important points. Focal length for a plane mirror, infinity. Focal length in general for a spherical mirror, r by 2. For marginal rays, r into 1 minus 1 by 2 cos theta. Mirror formula, 1 by v plus 1 by u is equal to 1 by v plus 1 by u will be equal to 1 by f. Magnification is height of the image by height of the object. In terms of image distance and object distance, minus v by u. Focal length and image distance, f minus v by f. Focal length and object distance, f divided by f minus u. Is that clear? For an inverted image, magnification will be negative. For an erect image or an upright image, magnification will be positive. And very important thing, this is very, very important. These 2 points are very, very important, guys. If you take a object and you are considering a spherical mirror, whether it may be a concave mirror or convex mirror. See, plane mirror, concave mirror, convex mirror. They are all part of certain sphere, guys. They're all part of certain sphere. Plane mirror will be a very small part of a large sphere. In the same manner, concave mirror or convex mirror, they are both parts of sphere only. Okay. If inner surface is silvered, then it is going to behave as convex. If outer surface is silvered, then it is going to behave as concave. So these all three, plane mirror, concave mirror, convex mirror, they are all part of a certain sphere. If we are taking a small part, either of the surface you silver, it is going to behave as plane mirror. If you are taking a considerable part of the sphere, if inner surface is silvered, convex. If outer surface is silvered, it is going to behave as convex. So these are the three types of mirrors that we usually study, guys. Now, when the object is moving along the principal axis, when the object is moving along the principal axis, image is also going to move. How will that image move, guys? It will move in such a way that minus of m square into velocity of object. And if it is moving perpendicular to the principal axis, then image is going to move. How it is going to move? Magnification times the velocity of object. I hope it is clear, all of you. So if object is moving towards the mirror, what is minus sign indicating? Minus sign indicates that it is going to move away from the mirror. You take image will move away from the mirror, guys. Is that clear, all of you? Is that clear, everyone?
So
How it
once
is
I
going? What happened?
so once again explain this point.
Which point? Which point? This point only.
Uh,
There is a derivation for this. I'm not going into derivation because of time constraint, right? So if you take an object, if it is moving towards the mirror along the principal axis, then its image is also going to move along the principal axis. But what will its velocity be? Minus m square times the velocity of object. And how will you find m value? In case of mirror, what is it, beta? Minus v by u, or f minus v divided by f, or f divided by f minus u. This is magnification. Very basic logic I will tell you. Let us imagine velocity of object, right? I'll take this component, okay? Magnification, so anyhow you can find. Let us imagine magnification is, let us say 1 by 2 or minus 1 by 2, guys. Okay, magnification let us say is minus 1 by 2. And when I'm saying velocity of object, I will take two components. Okay, so I'll take this component. This is object, guys. It has two components, let us say. Parallel to the principal axis or along the principal axis, it is 1 meter per second. And perpendicular to principal axis, it is 2 meter per second. Magnification, I'm saying it is minus 1 by 2. I'm asking you, what is the velocity of image? What will velocity of image be, guys? Chaftara? See, let us see this component first. It is parallel to the principal axis. So parallel to the principal axis, I will use this formula. Velocity of image is minus m square times the velocity of object. So how much is velocity of object? 1. What is m square value? 1 by 4. And minus sign indicates it is going to move opposite. So can I say you will get velocity of image something in this manner? And how much its value going to be, guys? 1 by 4 meter per second. Is this point clear? Is this point clear? I am talking about only this component. Which component is this? This is a component which is along principal axis. So whenever we have a component along principal axis, velocity of image will be minus m square times the velocity of object. The object has a velocity 1 meter per second. I am assuming magnification is minus 1 by 2. M square value will be 1 by 4. So I'll get velocity of image as 1 by 4, but minus indicates along negative x direction. Please tell me, but this is perpendicular component or not? Is this perpendicular component?
Yes.
Yes. So please tell me, what will its velocity be? Velocity of image be? Because of this. M times, no? M we got 1 by 2. 1 by 2 into 2 will be 1. But we got negative. So what does it mean? Here you are going to have something in this manner, guys. So this will be our 1 meter per second. I hope you understood. Is that clear?
Yes.
Right. Whoever had problem in this, always remember, if object is moving along the principal axis, right, towards the mirror, image will move away from the mirror with a velocity m square times of v naught. And if object is moving perpendicular to principal axis, image will also move perpendicular to principal axis with a velocity m times of v naught. I hope you have understood it, everyone. Yes or no?
Yes, sir.
Right. So I am not dealing with this part again. Okay, I'm not dealing with this part. However, we can just cross check it. I'll share these points with you people, guys. Now, the other major important part is, see, focal length will usually depend on radius of curvature. So if you take a mirror, I am placing the mirror and placing it in air first. It has some curvature. I am taking the same mirror and placing it in some medium. Will it have same curvature or not? Will curvature change? No, it is not going to change. So it's very important property again. Focal length of mirror will remain unaffected when it is dipped in a medium, guys. So you take a mirror, place it in free space, it has some focal length. You take the same mirror, place it in some medium. Will curvature change? No, because curvature is not changing, focal length is also not going to change. Another important point that you have is, if you take two concave mirrors, let us say there is some separation between them. D is the separation between them, guys, right? And I am placing an object exactly in between the two concave mirrors. They will ask you how much should be, or what should be the distance between the two concave mirrors such that final image is coinciding with the object. So there will be two positions, guys, right? The distance between them can either be 2 times the focal length, or distance between them can either be 4 times the focal length. Again, very important point. Derivations we cannot do, guys, so it's better if we just review it. Okay, I have clearly told it is a review session, it is not a discussion session again, right? Two concave mirrors we have. Object is placed exactly midway between the objects. they will ask you what should be distance between the mirrors such that final image will again lie on the object. So what should be the distance, guys? Two distances are possible. One can either be 2f, other can either be other can be 4f, guys. 2 times of focal length or 4 times of focal length. It means object can be placed either at focus, at common focus, or it can be placed at common center of curvature. I hope it is clear. Yes or no?
Yes, sir.
Right. Some more points are there, which I don't think are worthy enough of being explained. So I am not going in detail about that, guys. So let us move to the next image formation. I think you all are aware. Image formation. If object is placed at infinity, where is image form? Huh? In 10th class also you have studied. So class 11 students, we are not discussing this. However, in question, some or the other way we will get a question. So we will discuss during the questions again. Okay. So these were image formations for concave mirror and convex mirror. So just remember that if object is placed at infinity, image will be formed at focus, guys, and it's a very small image, so its magnification will be 0 again. If it is placed between infinity and center of curvature, object will be image will be formed between focus and center of curvature. It is again going to be a diminished image, so it will be lying between -1 and 0. So in the same manner, if the object is placed at center of curvature, image will also be formed at center of curvature. So magnification will be -1 exactly, guys. Right? So, and when you are moving the object closer to the mirror, as I said before, image will move away from the mirror. So when you are bringing the object between center of curvature and focus, image will be formed beyond center of curvature, and it will be a magnified image. So magnification will be more than 1 but negative, guys. So that is the reason it is written as less than -1. Less than -1 means -2, -3, -4, so on. And when the object is placed at focus, where is the image formed, guys? Image will be formed at infinity, which we all are aware again. And whenever it is placed between focus and pole, image will be formed, which is virtual image. So concave mirror can form both real and virtual. Plane mirror also can form both real and virtual. Convex mirror also, if you take, guys, convex mirror can also form both real as well as virtual image. I hope it is clear, right? So what do you need to know in laws of refraction again, right? Relative refractive index is important. So refraction, what is meaning of refraction? What do you mean by refraction? It is bending of light. Okay. You also have a term called as diffraction. Diffraction is also bending of light, right? Refraction is bending of light. Diffraction is also bending of light, guys. So when can I say the bending of light is refraction, and when can I say bending of light is diffraction? If bending of light is taking place at an interface separating two transparent media, then I will call it as refraction. And if bending of light is taking place at edges, at openings, then it will be considered as diffraction, guys. Bending of light at an interface, at a junction separating two different media, then refraction. Bending of light at edges or at openings, that will be your diffraction, guys. Okay. So same manner we have laws of refraction, I think, which you are already aware. So incident ray, refracted ray, and normal. There you had reflecting surface, here you will have refracting surface. They are all going to lie in same plane, right? Same plane. One more point to review, guys, right? Same plane means, can they form a three-dimensional object?
No.
No. If they are forming a three-dimensional object, we have a certain point called a scalar triple product. Three vectors are there. If they are forming a three-dimensional object, volume of that three-dimensional object will be given as a bar dot b cross c, right? So let us say incident ray, refracted ray, and normal, they are forming a three-dimensional object. What will volume of the three-dimensional object be?
0.
0. So here let us say E1 cap is unit vector of incident ray, E2 cap is unit vector of refracted ray, N cap is unit vector of normal. Then what will scalar triple product be given? E1 cap dot E2 cap cross N cap. I can also write this as E2 cap dot N cap cross E1 cap. Cyclic rule, guys. It's just a cyclic rule. I can also write it as N cap dot E1 cap dot E1 cap dot cross E2 cap. So this is volume of a three-dimensional object. But how much will this volume be? 0. It is going to be 0, guys. Clear? And we also have something called as Snell's law again. The ratio of sine of angle of incidence to the sine of angle of refraction, right, will be equal to a constant value for a given medium, and that constant value is called as refractive index, guys. Okay, and Snell's law, which we usually apply, mu1 into sine I will be equal to mu2 into sine R. The ratio of sine of angle of incidence to sine of angle of refraction will be mu2 by mu1, guys. Right? It is also written as mu21, right, which is refractive index of second medium with respect to the first medium, guys. Clear, all of you? Refractive index of second medium with respect to first medium, and in general, refractive index of any medium, if I take as a matter of fact, it will be given as C divided by V. What will it be given as? C divided by V, or it can also be given as lambda in vacuum to the lambda in medium. So refractive index, generally it is inversely proportional to the wavelength, guys. So if you have more wavelength, you will have less refractive index. If you have less wavelength, you are going to have more refractive index. Is that clear, everyone? Yes or no? Refractive index will be given as ratio of speed of light in vacuum to the speed of light in medium. I can also write it as wavelength in vacuum to wavelength in medium. Okay. Now, in general, whenever incident ray is traveling, this also you should know, whenever incident ray is traveling from rarer medium to denser medium, refracted ray will bend towards the normal. So as you can see, if there was no interface, incident ray would have traveled in this manner. But because of the presence of interface, is it getting deviated or not? So the deviation in this case will be written as I minus R. In the same manner, if it is traveling from denser medium to rarer medium, the refracted ray will bend away from the normal. In that case, deviation will be given as R minus I, guys. Two things we have. When it is traveling from rarer to denser, I minus R, denser to rarer, deviation will be given as R minus I. Why is there a deviation? Because whenever light is incident at an interface separating two transparent media, bending will take place. Because bending is there, deviation will be there. Suppose, please tell me, if I value is 0, let us take I value is 0. If I is 0, sine 0 will be 0 or not? So whatever may be the refractive index value, again, R value will also be 0. So how much will deviation be? 0. What is the meaning of I is 0? I is 0 means incident ray is along the normal. Whenever incident ray is along the normal, guys, it is called as normal incidence. It is called as what? Normal incidence. So for normal incidence, there will not be any refraction. No bending of light will take place for normal incidence. Is that clear? For normal incidence on a reflecting surface, what is the condition? If incident ray is along the normal for reflecting surface, will it retrace its path back or not? Yes, we got deviation as 180 degrees, guys. But if you have a refracting surface, how much is the deviation? 0. Two very important points again, right? If you take a reflecting surface, if incident ray is along the normal, reflected ray will retrace its path. Whereas if this surface is a refracting surface, if incident ray is along the normal, then that ray will move undeviated, guys. The ray will be moving undeviated. Is that clear, all of you? Yes or no?
Yes, sir.
Right? So that is what I have written over here. Whenever it is traveling from denser to rarer, R value is greater. So deviation is R minus I. And if it is traveling from rarer to denser, I value is greater. So it will be I minus R. However, when incident ray is 0, angle of incidence is 0, angle of reflection will also be 0. So deviation will also be 0 in that case. Unlike that in reflecting case, guys. In reflecting case, if incident ray is along the normal, deviation 180. In refraction case, if incident ray is along the normal, deviation how much? How much? 0, right? The other point that you need to remember is if you have parallel refracting surfaces, very important point which is used in glass slab case also, guys. If you have parallel refracting surfaces, right? You see, this is our incident ray. The final ray which comes out will be called as emergent ray, guys. How are these surfaces? Is this surface separating first medium and second medium? Yes. Is this surface separating second medium and third medium? Yes. Is this surface separating third and fourth medium? Yes. Is this surface again separating fourth and first medium? Yes. So whenever a surface is separating two media, what will take place? Bending of light, called as refraction again. So how are those surfaces? They are parallel to each other. So whenever we have parallel refracting surfaces, you see, this is our incident ray. This is our emergent ray, guys. Are incident ray and emergent ray lying in same medium? Yes, they are lying in same medium. So whenever we have parallel refracting surfaces, if incident ray and emergent ray are lying in same medium, then I will directly say angle of incidence and angle of emergence both will be equal. So you see, this is your angle of incidence and this is your angle of emergence. Are they both equal or not? Yes. What do I mean by both are equal? They will move parallel to each other. They will move what? Parallel to each other. So whenever they are moving parallel to each other, they are in the same direction. So how much will deviation be, beta? The total deviation by this whole system will again be 0. Clear, all of you? Initially it was traveling like this. Now also you see it is traveling in the same direction. So deviation will be 0. Very important case again, which is also used in glass slab. Whenever you have parallel refracting surfaces, for parallel refracting surfaces, if incident ray and emergent ray are lying in the same medium, then what is going to happen? Angle of incidence and angle of emergence will be equal. Will there be any deviation?
No.
No, there won't be any deviation. Now, as I have just now said, the how is refractive index and wavelength dependent, guys? We give it by a certain formula called as Cauchy's formula again. So what we basically write, the refractive index of any medium will be given as A plus B by lambda square plus C by lambda power 4. As we can see, refractive index is inversely proportional to wavelength. And we know wavelength of violet light is less than wavelength of red light. The refractive index of violet light will be more than refractive index of red light, guys. Is this clear? Yes or no, everyone? I hope it
Yes,
is
sir.
clear, right? The other very important point is real depth and apparent depth case, guys. This case will always be asked in exams again. Whatever exam it may be, definitely this case will be asked. Real depth and apparent depth. They are because of refraction. What is the reason for real depth and apparent depth? Because of refraction, guys. So very simply I'll tell you, if you take an object, you are taking an object, it is present in which medium? Denser medium, guys. If an object is present in denser medium, just a second, right? If an object is present in denser medium, what is going to happen? You take a fish, guys. If it is present in denser medium, right, it will appear to be at a certain height above its actual presence. In reality it is here, but if you are observing from a rarer medium, it will be present somewhere over here. Clear? So this will be your real depth, guys. So how much is the real depth here? X is given as the real depth. Okay, but is it present to us? In reality it is present here, but if you are observing from rarer medium, will it appear here only? No, it will appear at a certain height above its actual presence. So this depth is called as your apparent depth. Now, is this depth greater or lesser than real depth?
Lesser than real depth.
Lesser. So what I'll do, I will divide the real depth by refractive index. Or in general, I'll write it as x divided by mu 2 1. I will write, guys. Clear? So did it shift upwards or not? So how much will that shift to be? It will be real depth minus apparent depth. So what will shift to be in this case? What is real depth beta? X minus x by mu21. So if I take x common, I'll get it as 1 minus 1 by mu21. Mu21, just now I have told you, I can write it as mu2 by mu1, so which is mu1 by mu2. I hope it is clear. So where is the object here? In which medium is the object? A medium lundi by object. In which medium is it?
Denser.
Denser. Where is the observer?
Rarer.
So for an observer in rarer medium, if he is looking at the object present in denser medium, it will be present at a certain height above its actual presence. Okay. So here real depth is greater. Just give me a second. Reverse case if I take. Now you see next case. Where is the object? Denser medium. No, sorry, object is in rarer medium. Where is the observer? Denser medium. How do I identify denser and rarer? Very simple. If refractive index is more, that will be denser, right? Refractive index is less, if it will be rarer. So observer is in denser medium, object is in rarer medium. Again, for an observer in denser medium, object in rarer medium will again be at a certain height above its actual presence. In both the cases, you see, the image of the object is above the object or not? Yes. But here, if you look at this case, guys, this is our real depth. This is our real depth. But what is apparent depth, you see? In this case, is apparent depth more or not? Because it is more, I will take it as mu x, or I will write it as mu21 into x, guys. Understood, everyone? Now, how will you write shift as? Because apparent depth is more here, I will write shift as mu21x minus x, which I can write x if I take common, mu21 minus 1, or I can write it as mu2 by mu1 minus 1. Is that clear? Is that clear?
Yes, sir.
Right. Similarly, velocity of image will become, in first case, please remember like this. In first case, you will get mu1 by mu2. In second case, you will get mu2 by mu1. Please remember like this, guys. So in first case, velocity of image will be mu1 by mu2 times the velocity of object. In second case, velocity of image will be mu2 by mu1 times the velocity of object. Is that clear? Very simple cases. Whenever object is in denser medium, for observer in rarer medium, it will be at a certain height above its actual presence. Reverse also if you do. If the object is in rarer medium, observer is in denser medium, again the object will appear to be at a certain height above its actual presence. This real depth and apparent depth come into existence due to refraction. They are based on refraction, guys. Is that clear, everyone?
Yes, sir.
Right. In the same manner, you have one more case there, right? So they're asking, consider the following some illustration they have given. The bird is given and fish is given, guys. Fish is moving towards the interface with speed v1 or vf is given, let us say, and bird is moving with speed vb. So what are they asking? Velocity of fish as seen by the bird and velocity of fish as seen by rest frame inside the water they are asking. Okay, how will you basically understand this? In general, with respect to fish, I will take, guys. Let us imagine bird is at a distance xb, refractive index of water is mu, right? And fish is at a distance xf. Please tell me, in reality, if I see this, what is distance between fish and bird? If I am observing or you are observing, what is distance between them? Xf plus xb or not? But if fish is observing, guys, who is observing? Who is observing?
Fish.
Fish is observing. So let us say if fish is observing, what is going to happen? So very simple logic. I'll just discuss it here. Where have you gone? But I'll just show it here, guys. It is based on again apparent depth and real depth case only. Very simple logic that you should remember. Actual position of fish is here. Okay. Let us say this is our interface. Actual position of bird is here. There is some distance between them. Okay. This is actual position of bird. Who is observing? Fish is the observer.
Fish.
Who is the object now? Bird is the object. Now, for an observer in denser medium whose refractive index is mu, where will bird appear to be, guys? Will it be at a certain height above its actual presence or not?
Yes.
Yes or no? So
Yes.
initially, what was this distance? This distance was xf. What is this distance? This distance is xb. But what will this distance now become? Will it become more than xb or not? It is mu times of xb. So what I want to find here, I want to find the distance of the fish or distance of the bird with respect to fish. With respect to fish, at how much distance it is away, guys? It is xf plus mu xb or not? Yes or no, everyone? Array. No, you didn't understand it. Did you understand or not? Right? For us, if we are observing this diagram, what is distance between fish and bird? xf plus fb, xb. If fish is observing the bird, what is distance between fish and bird, guys?
XF plus mu XB.
This you understood or not?
Yes.
Yes. So what is distance of bird with respect to fish? It is xf plus mu xb. If I want to find speed of bird with respect to fish, what I'll do? Whatever distance is there, I'll differentiate. So I'll get rate of change of distance of bird with respect to fish. What will I write this as, guys? I'll write it as d by dt of how much do we have here? X of fish plus mu into x of bird. So I can write it as d by dt of x of fish plus mu times of d by dt of x of bird, guys. Clear, all of you? What is rate of change of distance? Speed or not? So this will be speed of fish plus mu times of speed of bird. This will be speed of bird with respect to fish. Clear?
Yes.
Can you tell me what will be speed of fish with respect to bird? Everyone understand this?
Mm.
Hello?
Yes, sir.
Right. Now I am asking you what is, I hope someone's mic is turned on. Please mute it, guys. What am I asking now? I'm asking you what is speed of fish with respect to bird? Right? So I'm just showing you the diagram here. This is bird in reality. This is fish in reality. Okay. So if we are observing distance of the bird from interface xb, distance of the fish from interface xf. But who is observing now?
Fish.
Who is observing? No, no. Fish का तो हो गया भाई.
Bird. Bird.
Bird.
So who is our observer? Bird is our observer.
Bird.
Where is it present? In which medium?
Rarer.
Rarer medium. Who is the object?
Fish.
Fish is the object. Where is it present?
Denser medium.
Denser. For an object present in denser medium to an observer in rarer medium, where will the object appear to be? Above f or below f?
Above.
Yes or no, guys? So this will be the apparent position of the fish. So please tell me, will this be our new distance of fish with respect to surface or not? But who is observing? Bird is observing. If you are observing, what is distance between bird and fish?
Mu XB plus XF.
xb plus xf. Is that clear, all of you? If bird is observing, what is the distance of fish with respect to bird? If bird is observing from here to here, how much? xb plus. Is fish going to be present here or not? What will I write? xf by mu. Is this clear, all of you? Are Ardhamainda, hello.
Yes, sir.
Did you understand, guys? As simple as that again. So if I want to find speed, what will I do? I'll do differentiation. So I'll directly write speed of fish with respect to bird will be speed of bird plus speed of fish divided by mu. Is that clear? Is that clear? So
Yes,
that
sir.
is what given over here. So these are called as real depth and apparent depth, or simply we call it as actual position and apparent position. Understood, everyone? Which is based on the concept of diffraction again. Clear?
Yes, sir.
Let us move to the next points, guys. Real depth, apparent depth, understood, all of you?
Yes, sir.
Right, refraction part. Hopefully, I'll discuss everything till prism, guys. Okay, and maybe optical instruments we will deal tomorrow. Again, whenever I'm discussing problems, they are very important. Review, though you may study anywhere, guys, but problems discussions are very important again. So please let us focus on that. Um, Again, with our heart and soul, everything. Whenever discussion of problem is taking place, please focus properly. Solve previous year questions. Those will certainly fetch you 35 questions definitely, guys. Okay. Glass slab again, right? It is just a rectangular object, guys, made out of glass, or cuboidal shaped object made out of glass again. So again, you see, this is one interface separating two medium. This is also again interface separating two medium. This is our incident ray. This is our emergent ray. Are they lying in same medium, guys? Again, whenever incident ray and emergent ray are lying in same medium, if you have parallel refracting surfaces, what is the condition?
Incident ray is equals to
Angle of incidence will be equal to angle of emergence. And what will be deviation? Zero. So will incident ray and emergent ray move parallel to each other or not? Yes. So if they are parallel, do they have a constant distance between them? That
yes.
distance only is called as your lateral displacement, guys. And it is given as t into sine of I minus r divided by cos r. It will be given as t into sine of I minus r divided by cos r. This is distance between what and what? It is distance between incident ray and emergent ray. Incident ray and emergent ray, guys. Suppose if you are taking very small angle of incidence, then that value will be ti into 1 minus 1 by mu. For small angles of incidence, if you take, the distance between the incident ray and emergent ray will be ti into 1 minus 1 by mu, where t is the thickness of the slab, I is angle of incidence, mu is the refractive index of the glass slab, guys. Is that clear? Yes or no?
Yes.
Right. Now, the 3 points in glass slab which are very, very important again, right? So, which we usually will consider here. Aravo. Right. Three important cases, guys, in case of glass slab, which are truly very important. So what are those three cases? You see, first case, here you have an object. Which type of rays are coming from the object? How are these rays? How are the rays, guys? Are they moving apart from each other or not? So those rays will be called as divergent rays. If divergent rays are coming from the object and you are making those divergent rays fall on the glass slab, then what will happen to the object? Object will move closer to the glass slab, guys. Which type of incident rays are falling on the glass slab? Which type? Divergent type. So for divergent type of incident rays falling on the glass slab, what will happen to object? It will move towards the slab. By how much distance? T into 1 minus 1 by mu. Very important again. Similarly, in the next case, you see, again, rays are falling like this or not? Right? They are moving towards each other. Whenever rays are moving towards each other, what will they be
Convergent rays.
called as? Convergent rays. So whenever convergent type of rays are falling on the glass slab, what will happen? In reality, object is here. You see, this ray should actually converge at this point. But when you are making this ray fall on the glass slab, is it appearing to converge here or not? So what has happened? Did the object move away from the slab, guys? Yes, it
Yes,
has
sir.
moved away from the slab. Two very important cases. Which type of rays initially? Divergent type of rays.
Divergent.
Divergent type of rays, if they are incident on glass slab, what will happen? The object will move closer to
Towards
the
the
slab,
plane.
right? And whenever convergent type of rays are incident on the slab, where will the object move?
Away
Away
from the
from the
glass.
slab. In both the cases, what will the shift be, guys? It will be t into 1 minus 1 by mu. In both the cases, the shift of the object or shift in the object will be t into 1 minus 1 by mu. Is that clear? Yes or no?
Yes.
Right. First, next, third important point that you need to remember in glass slab is, suppose plane mirror we have studied that object distance should be equal to image distance. Yes or no? So let us take a plane mirror. So if I say this distance is x, right? This distance will also be how much beta? X only. Yes or no? Now what we are doing is I am placing a certain glass slab in between the object and the plane mirror. You just try to see the case, guys. So in first case, what do we have? We have a object and image separated by a plane mirror. So object distance and image distance both will be equal, but in opposite direction. Okay. Now we are placing a glass slab in between object and the plane mirror. In this case, what is going to happen? You see, from object, which type of rays will come? What do I mean by object, guys? Object is that particular, again, you can consider it some general quantity only. From that particular object, what is going to happen? Incident rays are going to emerge, guys. Okay. Image is that particular point where reflected rays or refracted rays intersect. Object is a point from which incident rays originate. Image is a point. It is a point of intersection only. It is a point where reflected rays or refracted rays converge, guys. Clear, all of you? Now you see, from object, which type of incident rays falling on slab? Can you please tell? Which type of rays are falling on the slab, guys?
Incident.
Divergent.
Incident only. Which?
Divergent.
Divergent type. Yes or no? For divergent type of rays falling on the slab, what will happen to the object?
Move towards the glass.
Towards the slab. The object is going to shift towards the slab, guys. Whereas if we talk about the image, image will also shift towards the slab. If I say this is shifting by x distance, image will shift by 2x distance, guys. These three are very important points. Clear, all of you? There's a proof for this. Let us not go in detail about proofs. Just remember again, if you have taken an object, initially object distance and image distance from plane mirror same. I am introducing a glass slab between the object and plane mirror. What will happen? Because divergent type of incident rays are falling on the slab, object will move towards the slab and towards the plane mirror. Image will also move towards the slab and towards the plane mirror, but shift in the image will be 2 times the shift in the object, guys. Clear, all of you? Yes or no?
Yes, sir.
Yes,
Right.
sir.
Again, these three are important points in glass slab. Right. Glass slab has parallel refracting surfaces. Right. Because it has parallel refracting surfaces, incident ray and emergent ray will move parallel to each other, right? So angle of incidence, angle of emergence same, deviation will be 0. Distance between the incident ray and emergent ray is called as lateral displacement. What it is given as? It is given as t into sine of I minus r divided by cos r. And if you have small angles of incidence, then it is given as ti into 1 minus 1 by mu. It is given as ti into 1 minus 1 by mu. Is that clear, all of you? Divergent type of rays incident on slab, object will move towards the slab. Convergent type of rays incident on slab, object will move away from the slab. In both the cases, shift will be given as t into 1 minus 1 by mu. If glass slab is introduced between the object and the plane mirror, object will move towards the slab, towards the plane mirror. Image will also move towards the slab, towards the plane mirror, but shift in the image will be 2 times the shift in the object. Is that clear? Yes or no?
Yes, sir.
Yes,
Right.
sir.
Now, there is some concept called as critical angle, which is also very, very important. The critical angle case will rise when incident ray is traveling from denser medium to rarer medium, right? So it is that particular angle where angle of refraction in rarer medium becomes 90 degrees. So if I apply Snell's law, guys, it is traveling from mu2. So what is mu2 here? It is the refractive index of the medium in which incident ray is present. Here mu1 is the refractive index of the medium in which refracted ray is present. So if you apply Snell's law, what is Snell's law stating? Mu1 into sin I will be equal to mu2 into sin r. Yes or no? In general, this is the Snell's law. Right now, in this case, can you please tell what will Snell's law be? I to anyhow you know it is angle of incidence. R you know it is angle of refraction. Mu1 is refractive index of that medium in which incident rays are lying. Mu2 is refractive index of that medium in which refracted rays are lying. So please tell me, in this case, what will the Snell's law be? Can I write it as mu2 into sine of critical angle will be equal to mu1 into sine of what is r value here? 90 degrees. So what is sine IC value going to be? It will be mu1 divided by mu2. So if I say mu1 is 1, then I'll write it as 1 by mu. So I'll write critical angle as sine inverse of 1 by mu. So what is the point that you need to know here is, if incident ray is traveling from denser medium to rarer medium, if it is traveling from where to where? Denser medium to rarer medium, that particular angle of incidence where refracted ray in rarer medium will graze the surface, or angle of refraction in rarer medium becomes 90 degrees, is called as critical angle, guys. Okay. And if it is traveling from mu2 medium to mu1 medium, then what will critical angle be given as? It will be given as sine inverse of mu1 divided by mu2. If it is traveling from where to where? If it is traveling from mu2 medium to mu1 medium, then critical angle will be given as sine inverse of mu1 by mu2. Critical angle will rise, that condition will arise only when it is traveling from, incident rays traveling from denser medium to rarer medium. Clear all of you? Yes or no?
Yes, sir.
And whenever incident rays traveling from denser medium to rarer medium, if the angle of incidence is more than critical angle, then you are not going to have any refraction. You are not going to have, who is this here? Right. Then you are not going to have any refraction. All the incident light will get reflected back into the same medium. That condition is called as your total internal reflection. Critical angle, total internal reflection. When will these conditions arise? They are only going to arise if what and what are same, guys. What is the condition? They are only going to arise if the incident ray is traveling from denser medium to rarer medium. The angle of incidence where angle of refraction in rarer medium becomes 90 degrees is called as critical angle. If angle of incidence is more than critical angle, then a phenomena will take place called as total internal reflection. Clear all of you? Yes or no?
Yes, sir.
Both the cases will arise if incident ray is traveling from denser medium to rarer medium, guys. Is that clear? Right. Here, if angle of incidence is less than critical angle, will total internal reflection take place? Will total internal
No.
reflection take place? No total internal reflection if angle of incidence is less than critical angle. If angle of incidence is equal to critical angle, will total internal reflection take place? No again.
No.
Here also refraction will take place, but it is on the verge of total internal reflection, guys. Right? Just like we say, general equilibrium condition we take. On the verge it is. So it is on the verge of TIR. But will total internal reflection take place? No. Total internal reflection will take place only when angle of incidence is more than critical angle. And if the incident ray is traveling from mu2 medium to mu1 medium, critical angle will be given as sine inverse of mu1 by mu2. So it is one very important case, guys. So there is a, let us say a fish is present which is at a depth h. They will ask you from what area can fish view the outside world, right? Through what maximum area can fish view the outside world, or through what maximum radius can fish view the outside world if it is present at a depth h from the surface. So the maximum radius through which it can view the outside world will be given as, I think he has given some mistake over here. This is not correct, guys. So the radius through which it can view the outside world will be h divided by under root of mu square minus 1. It is not 1 minus mu square, it is under root of mu square minus 1. Is that clear, all of you? So what will the area be? Is it in the form of circle or not? The area will be pi r square. So I can write it as pi h square divided by mu square minus 1. Clear, everyone? Or they will ask you what should be the area of the disk. How much should be the area of the disk that I need to place on the surface such that I am blocking the vision of the fish. So same case, the maximum radius of the disk should be this much, maximum area of the disk should be this much. Clear, all of you? This is the maximum radius through which a fish or an object or an observer can view the outside world. This is the maximum area through which fish or the observer can view the outside world. If I have to block their vision, I need to place some object, some disc shape object I need to place. So what is the maximum radius of the disk or minimum radius of the disk? Not maximum radius, minimum radius. Minimum radius of the disk, it should definitely have this much radius, guys. Suppose if I take a disk which has less radius, will I be able to block the vision? No. Why? Because the fish will still be able to see from this part. Yes or no? So this will be maximum radius through which fish or observer can see outside world, or it is the minimum radius of the disk that I have to place on the surface so as to block the vision, guys. In the same manner, this is the maximum radius through which a fish or an observer can see the outside world, or this will be the minimum radius of the disk that I have to place on the surface such that I am blocking their vision. Is that clear? Yes or no? Yes or no, everyone?
Yes, sir.
We have something called as optical fiber also. Optical fiber is again going to work on, it is going to work on the basis of total internal reflection. It has two regions, guys. One will be the inner part called as core, other will be the outer part, the covering. It is basically called as cladding, and usually core will have more refractive index compared to cladding. So that is the reason whenever light travels from core to cladding, there is a possibility of total internal reflection to take place. Something like this. Clear, all of you? So whenever light travels from core to cladding, possibility of total internal reflection will take place. Why? Because core has more refractive index, right? So there is something called as acceptance angle which they usually give, guys. So what is acceptance angle is what should be the angle of incidence for which the light will stay inside the optical fiber only. It should not go to the cladding again. The maximum angle of incidence only will be called as your acceptance angle, and it is given as sine inverse of under root mu1 square minus mu2 square divided by mu naught. So usually mu naught will not be given. Mu naught will be taken as 1. So the maximum value of acceptance angle will be given as sine inverse of under root mu1 square minus mu2 square. And this value, beta, this is very important. Under root mu1 square minus mu2 square is also called as numerical aperture of the optical fiber, guys. It is also called as numerical aperture of the optical fiber. Clear, everyone? Surrounding medium, usually we take the value as air only. For air, we take it as 1. Okay. So for optical fiber, again, we can write it as sine inverse of under root mu1 square minus mu2 square will be the acceptance angle. Acceptance angle is maximum angle of incidence by or through which the light is entering the optical fiber, for which light will stay inside the optical fiber only. It is not going to come out of the fiber. So that is called as acceptance angle, and this value under root of mu1 square minus mu2 square will be called as your numerical aperture. And what will be the functioning of optical fiber? It is depending on which function, guys? Total internal reflection. Is that clear? Yes or no?
Yes, sir.
Let us move to the other part. Right, lenses part, basic part I'll tell you guys, and you can do previous year questions based on mirrors, right? Refraction part till lenses, optical instruments you can leave, and some part of lenses also. So whenever we have, till now we have seen plane refracting surfaces. You take a glass slab, we took a plane refracting surface only. We took laws of refraction. There also we took a plane refracting surface. What if we have a spherical refracting surface? Means a curved part separating two transparent media, guys. So whenever a curved part is separating two transparent media, what I'm going to apply? We are going to apply a certain formula. Mu2 by V minus mu1 by U will be equal to mu2 minus mu1 by R. If you have plane refracting surfaces, directly you'll apply Snell's law. Yes or no? For which surfaces? For plane refracting surfaces. What is a refracting surface? It is that particular surface which separates two transparent media, guys. So directly you'll apply Snell's law for plane refracting surface. Whereas for curved refracting surfaces, guys, I am going to apply modified Snell's law again. This formula again I'm going to get by using Snell's law only. Okay, so it is advanced Snell's law, we can say in some way, which is mu2 by V minus mu1 by U is mu2 minus mu1 by R. Now, all the measurements, as you all know, should be taken from pole. You see, from pole to object. Is it being measured opposite to direction of incident ray? Yes or no? All measurements should be taken from pole or optical center, we basically take. So is object distance being measured opposite to direction? Incident rays are like this. Is object distance being measured opposite to direction of incident rays? अरे हाँ या ना भाई? Yes or no यार?
Yes,
Yes.
sir.
Yes, sir.
So object distance will be taken as negative. In the same manner, you see image distance. All measurements should be taken from pole, guys. Right? You see this. This particular distance, is it being measured in the direction of incident ray? Yes, it is being measured in the direction of incident ray. So what will our image distance be, guys? Image distance should be considered as positive. And even if you take the radius of curvature, it is again going to be measured in the direction of incident rays only. So it will also be taken as positive. Now what about mu2? What is mu2, sir? Mu2 is the refractive index of that medium in which refracted rays are present or in which image is formed, guys. Mu2 is refractive index of that medium in which refracted rays are present or image is formed. Mu1 is refractive index of that medium in which automatically what will you say? Object is present or incident rays are present, guys. R will be anyhow radius of curvature. U is V and U are image distance and object distance respectively. Is that clear, everyone? Yes or no? This will be refraction at spherical surfaces or curved surfaces, guys. Understood?
Yes, sir.
Right. So because it's first day and I am expecting some more students to join also by tomorrow, I think. So whenever you have a holiday, I think, will you be willing to spare some extra time, guys? Because if I have to discuss everything in detail, then I have to give some extra time also. So we will jump to question solving quickly. I will just explain some important points and some important formulae, right? Because I don't think if I keep explaining it at this pace, I will be able to complete the required amount of syllabus by NEET exam. Okay. So 11 students, don't worry. After NEET is done, again, every day 1 hour in detail class I will be taking for sure. So I have started this with an intention to make it bigger only this time. Last time I don't know how it was. Maybe some kind of deviations came. Okay. So, so what I will be doing is I am planning on a bigger platform only, starting with the a little bit of crash course type, guys. But as soon as NEET is done, we will also focus on first year only, significant first year, for first year separate batch, for second year separate batch. So hopefully I'm planning on that. Let us hope that if almighty's blessings are there, we will be able to do that at a very minimal amount of cost also, or maybe no cost. I feel there is a problem with no cost, guys, because last time I didn't take any amount from you people, you didn't give any amount to me. So as soon as I stopped the classes, you people also didn't have anything to worry because you didn't pay anything. I also didn't have any kind of a certain consigns that yes, I have taken amount from them, so I have to teach classes, right? So I didn't have this kind of nature. So that was the reason this time I have kept some amount, right? And it is hardly, if you make a count, guys, per day it is 50 rupees, I think, right? So which is not a huge amount, I guess. So if you make a calculation, you will get per day 50 rupees only. And hopefully that is not a burden to any of them. If it is a burden to any of them, please let me know, right? I will always be at the forefront to help people, which you are already aware of, right? So please spread this information to everyone, because today's first day, we I think we went a little bit slow, but we cannot maintain this pace, guys. If I maintain this pace, I cannot complete anything. So I will plan it in a better manner, right? So we'll see how things will work out. But my major focus will be on making sure that you will understand how to solve a problem when you look at the problem. So in these 40 days, the intention is that, guys, and hopefully with your support, with Almighty's blessings, right, that intention will certainly be fulfilled by the end of before your NEET examination. So on that note, we will meet tomorrow again, right? So please spread the information to everyone. And I expected 50 people. I think we have around 25 people. Not a bad thing to start with, guys. 50% of what we expected, right? So not a bad thing to start at all. So hopefully we will meet tomorrow at the same time, and I'll end the session today here, guys. Clear? Any doubts in today's session, guys? All of you?
So,
G Vaishnav?
so when we are solving the question, I mean, when we are taking the displacement attained by object, when it is kept in the front of a glass slab, why are we taking the shift has to be t into 1 minus 1 by u?
We do that in apparent depth, real depth concept, no? If x is the real depth, we take it as x into 1 minus 1 by mu, no?
Yes, sir.
So it is based on that concept only.
Okay,
There's
sir.
a proof for that also.
Sir,
Let us not go in detail about that, okay? One
sir,
we
one more
take t
thing.
by mu, no, x by mu we take. You remember that?
Sorry, sir.
If x is the real depth, what is the apparent depth? X by mu.
X by v.
Yes or no? So what is the shift again? We write it as real depth minus apparent depth. It is simple as that.
Okay, sir. Sir, one more thing. So when we are finding the critical angle, we are
Hmm.
considering the I mean the sensor when we apply sensor we get that mu1 times sin I is equal to mu2 times sin r. But जब हम वहाँ पे apply कर रहे हैं तो we are taking the mu1 and mu2 as opposite. I mean we are
तो
taking
आपने
mu1 as
आपने आपने करेक्टली नहीं देखा शायद डायग्राम फिर. I'll just show you the diagram once again. Is the screen visible?
yes sir.
The right. You just come back to critical angle. So where is it? I think here. If you come back to critical angle, you just look at this. Right. What is mu1? I've just told you it is the refractive index of the medium in which incident rays are there. So you please see, this is our incident ray or not? Is this our
Yes sir.
incident ray, Vaishnav? In which
Yes sir.
medium is it present?
So mu2.
That is the reason I wrote mu2. Clear?
So we can interchange it. I mean there's no constraints
No,
regarding.
it depends on, it is not a constraint. Again, it is depending on where, in which medium incident ray is there and refracted ray is there.
Yes sir.
Clear?
Clear.
And you see where is
Yes
refracted
sir.
ray? It is grazing the surface. There is refraction and it is present in mu1 medium. So what is mu2 here? It is refractive index of that medium in which refracted rays are there. So in which medium are refracted rays there here?
mu1.
Mu1. Mu1 it is here. In this case, it is mu1. So I wrote mu1 into sin 90. Clear?
Yes sir. Clear.
Next, please. Any other doubt, guys? Is there any other doubt? Yes or no?
No.
Right. Mohammed Zubair is Maria, I guess. Am I right?
Yes, sir.
Who is Mohammed Zakir?
Sir, Sabahat.
Sawahat. Nikhat hai sir?
Sir, Habiba.
Habiba. Hemant to Hemant. Rahman Abid, okay. Sadhya, okay. Sueva Mahin, okay. Please join with your names, guys, next time onwards. Huh? Vaishnav is there, okay. Samiullah, okay. Maliha, Muskan, Mehreen, Fatima, Krishnaveni, okay. Huzaifa Sheikh. Huzaifa join करे क्या? Nabiha join करे. Who has joined? Farheen Sultana?
Sir, Sania Mehri.
Sania Mehreen. Okay. Afia is there. Tomorrow onwards, please log in with your names, guys, because I need to keep a certain strict vigilance on this also. Okay. Chalo, we'll meet tomorrow. Thank you for joining. Thank you for trusting me. And hopefully, whatever journey we are associated with for the next 35-40 days, hopefully it has to turn out to be fruitful, guys. We'll hope that. And we'll meet tomorrow. Till then, take care. Thank you. Bye bye, all of you.
Thank
Thank
you.
you, sir.
Thank you.
Thank you, guys. Take care.
Thank you, sir.
Thank you all.